First thing that you are looking at over here, you have a 5-number summary of the heights of trees 3 months after they were planted. And here are our happy little heights over here. And it has been shown to us in a box and whisker diagram below. So question 1.1, determine the interquartile range. Yeah, good. I'm happy with that. So what we're wanting to do is when we're looking for our interquartile range, we're saying that's going to be Q3 minus Q1. So this is Q3, that's your median. This is Q1. So we're going to say that it's going to be 53 minus 42, which gives us 11. Nice. What percentage of plants has a height in excess of 53 centimeters? What percentage of plants has a height in excess of? Okay, we're getting some answers in. We've got 60%. Let's see what else. Let's see what you think. Put your answers in the chat. This is a question that gets asked all the time, and it's a trap. But I'm going to show you what the trap is, so that you never fall for the trap again. Keep those answers coming. What percentage of plants has a height bigger than 53 centimeters? Looking at this box and whisker or 5-number summary. Okay, let's try and break it down a little bit. Let me ask you a different question. At Q1, that's my first quarter, right? So that means that this data here is 25% of my data. And then this part here up to my median is 25%. From my median to Q3 is 25%. And from Q3 to my max is 25%. That's what we're doing by breaking it up into our quartiles. So if we're saying what percentage of plants is greater than 53, it's 25%. And this is a question that comes up often, and it tricks people because they look at the distance and they think it can't be the same. But remember, it's always 25% in each of those. And now I hope you never fall for that trick again. Okay, between which two quartiles do the heights of the trees have the least variation? And explain. Oh my goodness, Testimonia. So much scandal this evening. Yeah, this isn't a trick question. It's just this distance over here. So it's either between M and Q3, or you could say Q2 and Q3. And the reason is there's the distance between them is the least. Cool. Take a screenshot if you would like, and then we are going to move on to question 2. Yeah, M is a quartile. M is because it's 20. A quartile is just a fancy word for saying quarter. So what that breaks it up to is when we have our min to quartile 1, we're just breaking up our data into quarters. So that's halfway, which is our median. That's a quarter of the way. That's 3/4 of the way. So each of those is a quarter. Each of them is 25%. And that's why M is a quartile. Okay. All right, screenshots, and then we move on. Cool. I'm going to have to zoom out for this one. Okay, so you have been given a cumulative frequency curve, or an ogive, and it shows the time taken in minutes for 140 people to leave an auditorium after watching a show. So we have 140 people in total, and we're looking at the time it takes them to leave an auditorium. So first question, estimate the number of people who took more than 15 minutes to leave the auditorium. I'll try and make it as big as I can. This graph irks your soul. Why? What has this graph ever done to you? So we're trying to find the number of people who took more than 15 minutes to leave the auditorium. So yeah, we're getting closer now. If we want to look, this is 15 minutes. Okay, so then we're going to try and get the equivalent on the side. And that takes us to about 100. And so we're asking how many people took more than 15 minutes. So it's all of these people who took more than 30 minutes. So I'd say 40 is a good range. Does that make sense? Okay. Estimate the number of people who took between 8 and 12 minutes to leave the auditorium. Yeah, no, that's fine. I know it's difficult to read off these graphs off your screen. We'll do one just now where you can draw it, and then it'll be in front of you. So I think it'll be a bit easier. Let's have a look. So now we're trying to find where 8 minutes is. So that's here. And then where 12 minutes is, that's here. So we're trying to look at what is this difference. So we're going from like there to about there. So we're looking at this. So I'd say like 35-ish. I'd go about 35, somewhere around there. Yeah, that's okay. As long as you understand the concept of it, that's more what matters to me. Okay, the modal class. Yeah, because they're not asking for the average, they're asking for how many people took between that time. So this number of people took 8 minutes and this number of people took 12 minutes. So these are all the people that took in between 8 and 12. Now be careful, it's asking for modal class. So think about how you're going to answer that. Yeah, there we go. So these are the values which have been plotted. Okay, and remember the modal class is the one where the jump is the biggest. So this dude over here, that's our modal class. So we're going to track to see where that takes us. That takes us to 11 to 16. So our modal class would be between 11 and 16. Steepest curve. Steepest curve equals modal class. Okay, and then the last one of this, use your ogive to estimate the interquartile range. So now what your goal is to try and find the interquartile range. And it's going to be an estimate because we're reading off a graph. So it's not going to be an exact number. Let's put a little hint on the board for you. Oh, yeah, and I think you're reading off the wrong axis. So when we're looking for our quartile ranges. So our interquartile range, we need quartile 1 and we need quartile 3. To find the position of those, so the position of quartile 1 is if we take a quarter times n plus 1. And you can round it up from there. And for quartile 3, the position would be 3/4 of n plus 1. So we're going to look somewhere around 35 for quartile 1. It's like somewhere there. And then let's make this 35. And then somewhere around 105 for quartile 3. So somewhere chilling there. And so let's see, this number, let's say that's like 9.5 minutes. And this one, we can say that's about 15.5 minutes. So our interquartile range would be 15.5 minus 9.5. And that's just going to give us 6. It's okay though. It's really hard to read off this on the screen. So if you struggled with that, please don't feel bad. I'm just going to write the answer down here as well so that you've got this for. So Yanda, when we're looking at medium or quartiles, you're always going to be looking at the position. And so then we're looking at the total number of people. We're looking at our sample size. So that we're always going to look on this axis and then track across to get our value. Okay, take a screenshot if you would like. Let me zoom out a little bit so you've got the question. There we go. Okay. I want to. Let's find this. Okay. This one's a little bit easier to read off. So this ogive is showing project marks for grade 12 maths learners. All mathematics learners handed in a project and all project results are represented below. Use the ogive to answer the questions that follow. So let's start with the first two. How many grade 12 maths learners are at the school? And then use the ogive to estimate the median. I'm just changing my chair quickly, guys. Okay. Yeah, that's fine. Good. It's good to estimate. Definitely is 118. So, because that would be 120. So each of these would be jumping up by 10. So we have 118 learners. I'll give you a little bit of time to try and figure out the median. Okay, let's see. So if I'm looking for the median, I want to look at position 59, so somewhere like really, really close to 60. I want to look at that position, and then I'm going to go all the way down, and I'm just over the line, so I'm going to go with 66%. No, for medians, quartiles, for quartile 1, quartile 2, which is your median, or quartile 3, you look for the position on the y-axis and then track to the x. So always find our position on this dude and then track down to here. So Uyanda, like where they asked how many learners, so like if I wanted to know how many learners got 70% or more, then I need to look at my percentages. So then I would look from here and I'd go across to here. So it just depends on what they're asking. If they're asking for anything to do with the marks, you would start on the X. If they're asking for quartiles or medians, you always, always, always come onto the y-axis. Okay. Next one should be nice and easy because we just did something similar. Use the ogive to estimate the interquartile range. So for our interquartile range, I'm not giving you the answer yet. I need Q3 minus Q1. And I have 118 learners in total. One more minute. One more Earth human minute, and then I will give you the answer. Okay. So the position of my quartile 1, I'm going to go, I think when you work it on the calculator, you get like 29 and a half. So I'm going to go with around 30 And then I'm going to go with around 90 as my estimate. So I'm going to go here for quartile 1 and zoom down. And that gives me about 56, let's say. And then for quartile 2, I'm going to go to 90. Which gives me about 76. So I'd say 76 minus 56, which gives me about 20%. So to get the position of Q3, we say 3/4 of n plus 1. So this would be 3/4 of 118 plus 1. And that gives you the position. And then you, oh, sorry, that should be Q3. And then you read off there. Okay. Okay, last question for this question. The top 20 learners will receive a certificate for excellence. What is the cutoff mark for people receiving certificates? So the top 20 learners. I like that, Abu. I do. So this is 118 learners. And we know 20 learners got a certificate, right? So, and this takes us over here. This would take us to 98. So going from 98 to 118, that is 20 learners. Okay. So this is the portion that are going to get certificates. These are my star pupils. They are all going to get certificates. So if I want to know what the lowest mark is of the people who are getting certificates, I just have to look at where that person is, and that takes me to 80%. So we first need to find our 20 learners over here, and then we can see what their cutoff mark was. Yeah, well, in this situation, Abu, the person who got the top mark got 100%. So that's insane. Okay, I'm just going to zoom out a little bit so you can take a screenshot with the question. And then we're going to get into a fun question. Okay. My students hated this question when I gave it to them in class. That's why I'm keen to give it to you. I can torture you as well. A riverine rabbit is one of the most endangered animals in southern Africa. It is estimated that there are less than 250 of them left in the wild. The mass of 60 of the rabbits is summarized by the box and whisker plot below. So they've told us that we are looking at 60 rabbits. And this is our box and whisker. And this is our mass in kilograms. 4.1, nice, easy question. Write down the median of this data. So have a look at your box and whisker and tell me what my median is. Do not forget units. Mm-hmm. Good. Nice job. Good job. Remember, your box and whisker always tells you the same information. This tells you our min. This tells you quartile 1. This tells you M or quartile 2. This tells you quartile 3. This tells you our max. This is always 25%. This is 25%. This is 25%. And that's 25%. So if I'm looking for my median is 1.7 kilograms. Now the fun question. I would like you to complete the frequency table below. So you need to figure out what A, B, C, and D is. And the only information you have is that there were 60 rabbits in the study and the box and whisker that you have above. I encourage you to talk to each other. So maybe write down your thoughts in the chat so you can see if you can figure some things out and do it through like breaking things down. But we need to figure out what A, B, C, and D is. I have given you a hint on the board already. This is definitely skewed to the left. Just highlight my hints. Interesting answer, Oyanda. Tell me why. I agree with you as well, Kimberly. Okay, so some of the answers that have come in so far that I agree with, A is definitely 2. I definitely agree with that. B, I don't agree with as much. Look at you, Oyanda. Yes, nice. Great job. So what Oyanda is saying is that the first 25% takes us to 1.5. That's over here. That is 25% of our rabbits. 25% of 60 rabbits is 15, which means if I add all of these up, I need to get 15. And that is how we can find out what A is. So that is goal 1, to find A. Clever, hey? Next goal is to find B. Yeah, Uyanda, you're right. C is 15. Yay! Getting all the answers right. My class was very angry with me when I gave it to them. Granted, it was a long time ago, but they were not pleased. Okay, we know that the median takes us to 1.7. So that takes us to our median, which means this is also 25%, which means that also has to equal 15. So B is going to be 8. And then this, just this one single line, takes us to quartile 3, which means that that has to be 15 rabbits. And the last 25% is also 15 rabbits, which means D is going to be 13. And now if you ever get a question like this in a test or exam, you are not going to get angry. You're going to be able to do it. Great question. Because each of these, whenever I break it up into quarters, so all of these quarters, they're each 25%, right? So that's 25, that's 25, that's 25, and that's 25. So we look at how many we have. We have 60 rabbits. So if I want to know what 25% of 60 rabbits is, that's 15 rabbits. So that means that in each of these quartiles, quarter 1, quarter 2, quarter 3, and quarter 4, I need to have 15 rabbits. How is 6 between? That's just telling you how many rabbits there were. So they just said there were 6 rabbits that were in between the weight of 1.3 kilograms and 1.4 kilograms. That's okay. Okay, let me just zoom out a bit so you can take a screenshot. And then I want to get you guys to draw an ogive. Okay, I need to zoom down to... Okay, I'm going to start with this part. The following frequency table below shows the distribution of marks of 200 in a mathematics competition with 80 marks available. First step. There are so many spelling errors here. I'm going to just fix those for you quickly. First step, complete the cumulative frequency column. So that is this dude over here. And then we're going to draw the ogive. Remember, cumulative frequency isn't scary. All we do is we take the number above and we add on the next one. So now we're going to say 20 plus 40, which gives me 60. 60 plus 60, 120. 120 plus 50, 170. Plus 20, whoop, plus 10, plus 0, plus 0. So what the story is saying, there are 80 marks that you could get. So the top mark you could get is 80 out of 80, but there are 200 students in the competition. And now using those numbers, you are going to plot your ogive, little ogive graph. So remember, this is always telling you our total sample number. So that's saying we have 200 students in total. And hopefully we get a nice S shape. That is what I'm hoping for. How many Earth human minutes do you need? Let me know in the chat, and that is what I will give you. Sure. Okay, last few seconds. Are we seeing some S's? Hopefully. Yeah, in the end, you should have a straight line. Yeah, because it stays at 200. Okay, so there's a couple of things we have to take into account when we have an ogive. We don't take the middle mark for an ogive. We always take the upper boundary. That's our X value. And our cumulative frequency is our Y value. So my coordinates here would be 10 and 20. So I'm just going to quickly fill this in. So I'm going to go up in tens. And here I'm going to go up in 20s. Okay. Leander, did you get an S? I hope so. I'm going to find 10 and 20, and I'm going to draw my first dot. Remember, this one gets anchored. This one gets grounded. Next one I have is 20 and 60. So 20 and 60. Then I have 30 and 120, 30 and 120. I've got 40 and 170. Then I have 50 and 190. And 60 and 200, 70 and 200, and 80 and 200. And so then when I connect my dots, I should get a little S. I have to label my axes. So this side is my cumulative frequency. And down here is the maths mark. Yay, for getting the right shapes. Okay, now you have a few questions. Let's start with just the first two questions that you're going to do off this graph that you've drawn. And now you've got it in front of you, so now you should be able. You absolutely should have a heading. Thank you for reminding me. Ogive showing maths marks. Okay, write down the modal class. Okay, we've spoke about what a modal class is. Write down your modal class. So modal class is looking at our biggest jump. That's our biggest jump there because that's jumping up 3 blocks. So that's our biggest jump. And so then we're trying to look at where does that fall in between? And it falls in between these two sections. So we'll say our modal class is between 20 and 30. Oh, Yanda, what are we going to do with you and your axes? Okay, let's write down some things. So, so Q1, Q2, Q3, M position. We start here. Modal class, you look for the biggest jump. And then look down. And if we have specific numbers, we'll look on the x-axis and go up as well. We'll write that down when we get to those questions. It's okay. So now for 7.4, when you're trying to find the interquartile range, you're going to find the positions of quartile 1 and quartile 3. You're going to track them across and then find out what their maths marks are. Yeah, that's pretty close. So I would say quartile 1, so positions of quartile 1, I would say is about position 50 and quartile 3 is about 150. So if I go to 50, so that's quartile 1, and I track across, it looks like it's about 18. And quartile 3 at 150, like 38-ish, 37, 38, somewhere around there. So I'm only at 20, but I think if you got anywhere from like 17 to 22, I would probably have given that to you. Yeah, I think it depends on what your graph would have looked like. Okay, this is a good question to have again, because this was one that people struggled with. The top 40% of the students will be enrolled for advanced mathematics. Determine the cut-off mark. The top 40% of students will be enrolled for advanced mathematics. Determine the cut-off mark. I see. I'm trying not to give away if it's right or not until I have more answers in the chat. Okay. Oh, Naughty! Yeah, you've been quiet. Hello. Okay, so the first thing to do is I need to know what 40% of 200 students is. So 40% of 200, so that I actually know what I'm dealing with. It takes me to 80. So 80 of the students are going to be enrolled into advanced mathematics. Okay, so that takes me to 120, because that is 80 students, and that takes me to 30. So the cut-off mark would be 30 out of 80, or 30 marks. So careful again, it's not percentage, because these are just marks. These are marks out of 80. Nice job. Okay, I'm going to zoom out so you can take a screenshot. We're not going to do the last question on this one because it's standard deviation. And let's quickly do one more box and whisker before the end of our lesson. Oh yeah, no, yeah. But this isn't a pass. This is to get into advanced maths. It's a hard test. Okay. Okay, details of the number of WhatsApp messages sent by different sample of 39 girls are as follows. The lowest number of WhatsApp messages is 27, and the range is 60. The upper quartile is 72, and the 10th girl in the ranked data sent 35 messages, and the 20th girl sent 50 messages. Determine the highest number of WhatsApp messages sent by this sample. So the lowest number was 27, so that's my min, and the range is 60. So 27 plus 60, which gives me 87 messages. How many girls sent more than 72 text messages? I would say, what's 25% of 39? And that gives us like 9,75. And I can't have a portion of a girl, so I would say 9. No, because not quite 10. So they weren't 10 of them didn't send. So if I round it up to 10, then I'm saying too many. So you have to round this one down because I can't have 0.7 of a person. Okay, using the information you have. So you've got quite a lot of information here already. You've got some important things happening over here. Draw your box and whisker. If you said 10, I'll give this to you. That was mean. But I can't give you 8, Abu. If you said 9 or 10, I'll give it to you. So we have to just go on what information we've been given. So we've got our min value, which is 27. We've got our max value, which is 87. We know that quartile 3 is at 72. And then they've told us the 10th girl sent 35 and the 20th girl sent 50. So it's going to be around those values. So we're going to we have to use what they've given us. So it's not going to be super accurate, but it's going to have to do. So we're going to say that this one is about 35 and this one is about 50 and then this one is 72. So here's our box. And there are our whiskers. And can you please comment on the spread of this data? Which direction is it skewed? Remember, we always look at that. Good. It is skewed to the right or positively skewed. No, I know, Yanda, it's messy because but the thing is, it's the only information we have. So we have to kind of estimate because 39 people, we obviously can't break them up into 4s. So we can break it up into 10 people, 10 people, 10 people, 9 people, or 10, 10, 9, 10. But it's the best we can do. Okay, my lovely 11s, on that note, I hope you all have a lovely little evening.